process I'm using at this point is I'm cutting the top and the bottom off the can with a shop knife. And the thing that's nice about the shop knife is it's very strong, very sharp, maintains its sharpness, but can be changed out very quickly. So here's the top of the can, and I'm putting it into a bag here to be used separately in the system, processing system. I might be actually melting those into ingots for storage, or I might try to drop the molten aluminum into a kind of a waterfall type situation with air blowing on it to try to make it into the smallest piece as possible, but that's down the road. So anyway, you cut the top and the bottom off, and then you use scissors to cut it in half, and then you use a paper shredder and you feed it through the paper shredder, which seems to be working really great. Then I take the shredded aluminum well, I'm going to spell it that way, but you can see the little shreds of aluminum. That works really great for that. And then the next step I'm using is a blender with water and those shreds. And as you can see, there's a layer here of the aluminum on the bottom. When I started out, this was mounded up out of the water, probably about here. I ran this about 5 times through the blender, probably running a little bit more. As you can see, so you have the aluminum particulate in the water, which of course would be ideal, but then also you have the smaller pieces. And so I'm going to keep blending this, and hopefully, I mean, it'd be great if I could, after a period of time, have it all just the black water, because then that would easily flow into the system and to use my automated system. So I'll show you the blender working. So you'll stick with me. I will continue on in my next video to react this solution that I am creating, and we'll see if that gets a really good reaction in the reaction chamber, making a lot of hydrogen, and if it's worth doing. So here you see the shredder and the shreds of aluminum. That's the mechanism that shreds. This is the container that catches them. Shreds of aluminum in there. And then over here, I put the shreds of aluminum into this blender. And I hit the button that says soups. So I want to make aluminum soup. All right. The first step of aluminum soup. But I like to do it more than once. Now notice the thickness of the material and the blackness of the water. Now we'll go over and get my, let's see, where is that? This is like that game, Hidden Objects. Can you find the temperature reader. Here it is. I knew you could find it. All right, so we'll see that the outside temperature is 80 degrees. Now let's see what this is. 117. I think I'm going to do it one more time, but this time I'm going to hold it with a towel. You want some more soup? Let's check the temperature. 133. Perfect temperature for soup. Come bring your bowl and I'll ladle you out some. It's really good for your health. Hey, it's a Reckless Retiree here. And I'll be showing you my process for taking the cans from can form to particle form. And this is the results I've gotten so far. You might ask how many cans this is. I don't know. I didn't pay attention. So I have a further test in the future to determine how many cans makes up this amount and how much hydrogen can you make with this. The whole point was to make it, give it greater surface area. And I think in the process, for the most part, I've gotten rid of the labeling. This seems just really silver. But what I thought about doing next, just because I can, I have these filters, these sieves, used for mining, for gold mining. And I thought I would filter down this stuff just to see what kind of, how much of each size I have. So basically I have a half a cup here. I will pour that into the top of this. And I will shake it down and see how much of each size I have. And I will put each size in a separate Ziploc bag. And then I'll test to see how each one reacts with the lye in regard to making hydrogen, how much hydrogen can be made. I think the finer it is, the more surface area there is, the more hydrogen you should make. Of course, the question is it just a matter of speed? In other words, if I took the cans and put them in the lye, would they make the same amount of hydrogen as the finest dust that I create? And it just makes the hydrogen a lot faster when it's finer, or will it actually make more being a fine dust? Now, the main reason I was doing this, as I explained, was to make this pourable. So I want to have this in a pipe with a valve, and I want to be able to, well, actually a couple of valves. I want to have the section between the two valves, the ideal amount of hydrogen to add each time to the reaction chamber. So pour this material in the top of the upper pipe, and then open the one valve and close it. Now you have a closed off section of the exact amount you want. And then when you want to add it to the chamber, then all you got to do is open the second valve, the closest valve to the reaction chamber. It'll dump that into the reaction chamber, and you don't have to open things. You know, the reaction chamber will remain closed the whole time. And ideally, what would be nice is to draw a vacuum. Unfortunately, my vacuum pump has died, and I'll need to, at some point, buy another one. But that way you have no oxygen, no air in the mixture. just the hydrogen. And that's what you want, for, especially for compression into a storage vessel. So I finished filtering out the different sizes of particles, and there are 12 different sizes that I have here. The smallest being 100 grit, and the largest being 2. And then the most available as 8 or 20. That's pretty kind of interesting, isn't it? So my intent is to take the same amount. I haven't decided if I'm going to do it by weight or volume. Let's say a tablespoon. Take a tablespoon of each size grit and react them with the same amount of lye and water, and see if the size of the grit makes a difference in the quantity of hydrogen. I'm not really that concerned with the speed, but the quantity. If the quantity is the same, then there's no point in separating the aluminum that I have made into particles in the blender. And so then, I mean, they all will feed easily, pour, flow, however you want to say that. And like I said, I'm going to hook up some pipes into my new reaction chamber, which I have ordered. And the new reaction chamber is a stainless steel paint sprayer. You take the top off, you put the paint in, you seal it, and then you pressurize it, then you use that to spray paint. And in my case, I'm going to use it to spray hydrogen, actually. Flow hydrogen, I guess you'd say, and collect it. And so that's the idea. So my next video will be the testing of the different sizes. And if, like I say, if it's different, if I get more hydrogen with the size of the grit, then figure out a way to get the larger sizes smaller, which may be just blending them more. I don't know. I mean, if I made 100 grit out of the same blending technique as I used for the 2 grit, then it's probably just a matter of time blended. So that's a possibility. So stay tuned to the next exciting adventures of the reckless retiree. Ha ha ha.